All right, Mikey Taylor, welcome to the Nootralize podcast.
Thank you for having me.
Would you be so kind and tell us a bit about yourself, your history, and what you do?
hmm Yeah, so I'm Mikey. I'm 16, and I'm really interested in utilizing like exponential technologies and looking at how we can basically engineer happiness based on things like genomics and using brain-computer interfaces and artificial intelligence. So right now, I'm really interested in how we can use artificial intelligence with this field called connectomics. And connectomics basically looks at how different parts of the brain are related to each other, so how different parts of the brain are connected to each other. So I'm really interested in how we can utilize artificial intelligence to personalize different treatments for different neurological and psychiatric disorders. Because right now, I think that something that's really flawed in our diagnostic system is how we diagnose these different psychiatric disorders. So right now, all of our diagnostics are basically based on symptoms solely. And that doesn't really make any sense because right now the misdiagnosis rates for these different disorders are really high. And with like the power of science and utilizing personalized or precision medicine and looking at, okay, let's look at the genome, let's look at the metabolome, let's look at the proteome, and think about how we can personalize different medications and different treatments for the individual to optimize their recovery.
Right. How did you get interested in treating mental illness?
Yeah, so actually growing up, I dealt with a lot of struggles. Generalized anxiety disorder. I have really bad OCD,
Mm,
but I remember I actually OCD is the main thing that I deal with. And growing up, I wasn't actually diagnosed with OCD until I was probably around 14, and I had really been with it for all of my life,
yeah,
but I wasn't actually diagnosed with it until 14. And it was like between that time, I probably could have gotten treated earlier and my symptoms would have been a lot better compared to where they are now.
right,
So now I'm trying to look at, okay, with that personal experience in mind, how can I help other people so they don't have to go through the same thing? So basically, how can I optimize making treatments earlier and more effective for like optimal recovery?
right.
Mhm.
And how is your current experience with OCD?
Mhm.
Have you gotten help from any medications, or what treatments have worked for you?
Mhm. So being honest, therapy and medications weren't like what really did it for me. That wasn't really what helped, honestly. What helped was just really reading other people's stories and what they dealt with and looking at how I can like change my mindset. Basically, honestly, like the medication and all those things, that's not really what helped me the most. What helped me the most was, being mindful and like meditation. That's something I swear by. That helps me so much. And, getting enough sleep. And there are so many things we can do that don't necessarily require medication. So it's like, how can we personalize those other things that you can do to create treatments for these different disorders? Because so that's what's really helped me the most.
Right. Do you think that it is possible to, based on the genome and our understanding of the genome and the proteome, for example, and other omes,
Yeah.
to to personalize our recommendations of treatments that aren't medicines, such as mindfulness?
Mhm. Oh, yeah, I totally think so. I mean, right now, we still need to get a better understanding of the genome and the different genes that contribute to different things like mindfulness. There are really studies coming out every single day about like a new gene or something like that. Like, oh, we discovered this gene's function or something like that. But I totally think that there are certain genes, and there's also probably certain factors in the epigenome. So basically, the factors that affect gene, like transcription factors, factors that affect gene transcription, they totally contribute to mindfulness. I mean, there have been a lot of preliminary studies that show that like different factors in the epigenome can contribute to, what genes are expressed and therefore contribute to different thought processes.
But how could we, based on this knowledge, give recommendations for this is how you should meditate? Do you have any understanding of that?
I mean, really, it's really cool to talk about, but like, there's not a lot of like actual, like tangible things like that yet.
Right.
But I mean, I think in the future it will be possible.
So, can we go a bit deeper into what is the human connectome?
Yeah. So, yeah, I'm really interested in this field called connectomics. So basically, connectomics looks at how different parts of the brain are structurally connected to each other, and also looking at how different parts of the brain are functionally correlated with one another. So there's a really big project right now called the Human Connectome Project, and the Human Connectome Project basically aims to map all 100 billion neurons in the brain. Obviously, not an easy task. There are a lot of different ways we're going about doing this, but the reason why this is so revolutionary is because right now, the way we're studying the brain is so outdated. So we're basically looking at a map of the brain that was made in 1909 or something like that, like a really long time ago. And the brain's basically divided into some like 50 something regions, but obviously there's 100 billion neurons in the brain. And, the brain is so important. It controls everything, yet it's the organ that we have the least understanding of, which makes absolutely no sense. And there are more neurons in the brain than there are other cells in the body, which is insane. So it's like gaining a better understanding of how our brain functions and how it works is key to doing things like engineering happiness, finding out which type of meditation is going to work for you, figuring out how we can personalize different treatments and medicines for these different disorders.
Right. And what is it that you're doing currently? I know you are developing this machine learning, what would you call it?
Yeah.
Tell me more about it.
Yeah, so I'm really interested in this field called functional connectomics. So functional connectomics basically looks at how different parts of the brain are functioning with each other. So right now I'm interested in this thing called resting state functional magnetic resonance imaging. So basically what that looks at is different blood concentrations in the brain when we're not doing a task. So basically an fMRI is when you look at different parts of the brain in terms of the blood level. So basically when certain neurons fire in a certain part of the brain, more blood goes to that part of the brain. And then when more blood goes to that part of the brain, we can detect that more easily. So basically looking at how the brain functions in the resting state, because basically there's a lot of research right now that shows that these different disorders, there are misfunctions and hyperconnections and hypoconnections in different parts of the brain when we're in our resting state. And that's basically when we're just self-referential thinking. We're not actually doing any task. There's not really a stimulus. So right now what I'm doing is I'm analyzing fMRI time series that are actually available online. So I'm looking at different disorders like schizophrenia and bipolar disorder and OCD because, that's something I deal with. And I'm analyzing these, and I'm actually trying to train a machine learning algorithm to be able to diagnose these different disorders based on the functional connectome or how the brain functions.
Right. And how does that work in practice? What is it that you are doing when you're developing it? Yeah.
So first of all, like when you get the data, it's really messy. So you have to do a lot of pre-processing. And so what you can actually do is you can divide the brain into some 100 different regions. It's called an atlas, and that's how you parcellate the brain. And you can kind of think of it as like connect the dots. Okay, you can think of the brain as a bunch of different dots, and like an edge between two parts of the brain is like a functional dependency of those two parts of the brain. So what I'm looking at is how the time series, so basically the blood concentrations of certain parts of the brain are correlated with each other. And then once you do that, if two parts of the brain are really correlated with each other, then you can draw a line between those two parts of the brain. Or if two parts of the brain aren't correlated with another, then you don't draw a line between them. So then you can actually do this across a ton of patients and figure out, okay, what's the connectivity value between the salience network and the default mode network in this patient, and what's it in this patient, and what's it in this patient, and then repeat that over and over again, and do that for people with schizophrenia and healthy controls, and then looking at the differences between those two groups based on the functional connectivity. But unfortunately, it's not really that easy, because we can't just look at the differences by like finding the average difference or something like that, and that's where the neural network comes in. So basically, a feed-forward neural network, and right now I'm experimenting, with different architectures, but a feed-forward neural network to be able to differentiate these different disorders, basically using supervised learning. So labeling the data points. Okay, like I'm gonna put this data into the neural network. This is what somebody with schizophrenia looks like. This is what a control patient looks like. And then the network will be able to learn and adjust its weights based on those inputs, because I gave them labels. And then after that, I repeat the process over and over again. Then I can finally test it and then see, okay, I'm going to put in this data from a schizophrenic and see how this neural network performs, and then optimize it based on how the neural network performs with the training data.
Right. How is this more personalized than the traditional approach?
Yeah. So right now, obviously, it's only based on symptoms, which makes no sense. I mean, the rates of misdiagnosis are wicked high, and there are a ton of consequences if you're diagnosed with the wrong disorder, such as like right now ADHD. It's at a high, and some people who are diagnosed with ADHD may not even have it, and if they're treated with medication for ADHD when they don't have it, that can have really harmful effects. So looking at how you can actually look at the brain and get a more scientific basis of how you can personalize treatment. So basically, if there isn't a connection between these two parts of the brain in a certain disorder, then what you can look at is, okay, how can we increase those connections, that connection between those two parts of the brain more? And there are a lot of different things you can look at. Deep brain stimulation, that's kind of a hot topic right now. And looking at, okay, if these two parts of the brain aren't functionally connected as they should be, how can we use deep brain stimulation to specifically target that part of the brain in somebody with this disorder? And then say somebody with schizophrenia does have that connection in the brain, looking at other connections and how you can personalize deep brain stimulation based on that one part of the brain. And as we're going more and more into functional connectomics, there's a lot of research right now that's looking at genomics and how different genes are contributing to functional connectivity in the brain. So that's also a way you can look at, okay, how can we personalize medicine based on those genes? And the personalizing of the medicine and the different treatments and things like that, that'll probably really come in later, because right now, you have to gain all the data and you have to look at, okay, somebody with their functional brain looks like this, and then we gave them this treatment. How does their output look? So you have to kind of repeat that process over and over again to get the training data, and then you can test it.
Right. So currently, the goal, like the sub goal, is to understand the differences between a control subject and subjects with psychiatric disorders, right?
Yes. Yeah, actually finding like the neural biomarkers.
Right. And in the future, we want to use that knowledge of the difference between a healthy control and a person with a mental problem, and personalize the treatment to the individual brain scan. Is that correct?
And not even just the brain scan. Really bringing it across like a multi-phenotypic scale. So looking at different genes too, along with that brain scan, and also even different digital biomarkers, like using this thing called natural language processing to, you know, look at something like text messages between people and doing a risk assessment based on their certain text messages and incorporating all of this data into basically taking a bunch of data and then looking at, okay, how can we personalize treatment based on this person's, all of their data, basically.
So are you saying that if you want help with some mental illness, then in the future we may be able to, based on a person's text messages, treat that person better?
So not exactly. Basically, the goal is that would be for something more like diagnosis. So, you know, doing a risk assessment. But then the more scientific things like, you know, your brain, the genome, the proteome, that is where we're going to be able to really personalize those medications.
And can you tell us a bit more about the genome and the epigenome and what that has for a role in this personalization project?
Yeah, so there's a lot of data coming out now that's showing that, you know, certain genes are contributing to these certain disorders. And so, you know, like schizophrenia and bipolar disorder, some of them are inherited. So looking at the genes of people who have another family member with a certain disorder, then looking at the genes of people who don't have another family member and seeing if these things are inherited. And what we're finding is a lot of these different disorders have a genetic background. So now looking at, okay, how can these different medications, how are they working with these people? And then once we do that and do a lot of trials and stuff, then we can look at, okay, how can we personalize these different treatments based on, you know, somebody who had a similar functional connectome to you, similar genes, similar epigenome. How did they do with this certain medication? And then looking at, okay, well, if they didn't do well with that medication, then we'll try this one, and then eventually getting a lot of data that you're going to be able to create a more accurate diagnostic as well as more personalized treatment to that individual.
Right. And do you know if there are any bigger players, so to speak, than you sitting by yourself, I guess?
Mm-hmm. Yeah.
You're working, yeah?
Mm-hmm,
You're working on this by yourself, right?
Yeah, I am working on this by myself. There aren't really any companies doing exactly what I'm doing. I mean, there are people are trying to personalize medicine for these different psychiatric disorders. I mean, it's something we're doing with like cancer lab, but there isn't as much people doing it with different psychiatric disorders. And there aren't, to my knowledge, there aren't any other big corporations or companies taking as much data in as I'm trying to do and trying to create that more accurate diagnostic based on all of this different data and combining all of this different data. Because right now, I mean, there have been studies with, you know, things like the functional connectome diagnosing different disorders based on the functional connectome, but there aren't a lot of studies that also incorporate genomics and the epigenome and the proteome.
So in this machine learning project of yours, you're actually taking in data from all of those sources.
Yeah, so yeah, that's what I'm attempting to do. So obviously I'm doing this by myself. So, you know, it's not something that I can do really quick. So right now my main focus is looking at functional connectomics. And then as I get more comfortable with that and finding significant differences between groups with that, then I'll start looking at, okay, the different genes that can come into play.
Right. Cool. This has been really interesting, and I really appreciate you coming on the podcast. Where can people learn more about you and your project?
Yeah, so I have a Medium where I publish articles, and I have a whole profile on this thing called the Knowledge Society. So basically, I'm 16, and I'm part of this program called the Knowledge Society, which is basically if you're a teen and you're really interested in technology and how it's going to revolutionize the world, you can join this program called the Knowledge Society, and it's basically like an innovation incubator for teens. So I have a profile on their website. I'll send you the links to those, but yeah.
Yeah, I'll include those in the show notes for our listeners as well.
Okay.
Yeah, thank you for coming on the podcast.
All right, thanks so much.